on diagonal scale. So first, diagonal scale represents a unit and its fractions up to 2 decimal places. So for example, you can see 6.48 is the example of a diagonal scale. Why? So we are having a decimal point after the 6 and we'll be having 48 means 2 points after the decimal point. That means we can find out or we can measure any distance which is having unit and its fraction up to 2 decimal places. Also, we can measure up to 3 interconnected units. As you can see, here I have stated some figure 438, so in which you can deal with 3 different units. So now, you can measure unit and its tens and even hundreds. So let us see one example of the diagonal scale like this. So how to represent this diagonal scale? So we'll be first having total of 3 scales. So let us understand about these 3 scales in the diagonal scale. So the first scale you can see from 0 towards your right hand side is nothing but your primary scale or a main scale. The scale on the left hand side of your 0 would be your secondary scale, and there is one scale vertically there on the left hand side portion. It is nothing but your tertiary scale. So in diagonal scale we will be dealing with the 3 units. So for that we must have 3 different scales. So how to construct a diagonal scale? So first of all, we need to find out which is your primary or main unit. After that, the first task would be to draw one straight line and divide this straight line into suitable number of equal parts. After dividing this line, you should divide the first division of that line into subdivision or your secondary scale. After constructing your secondary scale on the left hand side of your 0, you should construct from the leftmost point of your subscale upon vertical scale, which is nothing but your new scale, and it is also known as your tertiary scale. So now after that we should give the notation to this scale. So you should give 0 at the end of the first division, as you can see. After that you should start giving numbering on the rightward fashion like this up till your 500. This will construct your primary scale. You should specify the unit of that primary scale on the scale itself. So here in our case this unit is meter. We have specified meters here. After that, from your 0 towards the left hand side, you should divide that portion into some equal number of subdivisions. So let's say here in our case, I have divided my diagonal scale into 10 number of subdivisions on the left hand side of your 0. After that, you should select the last subdivision of that division on the horizontal line, and from that last subdivision on the vertical line, you should divide that vertical line into one new scale. It is also known as your tertiary scale. You should divide your tertiary scale depending on your tertiary unit. So here in case, we are having our tertiary unit also in meters. That's why I have divided this vertical scale, tertiary scale, also into 10 equal parts. After that, we should specify each and every unit below that scale. So first of all, let us start by specifying the unit of first your primary scale. So here primary scale is specified by unit meter just below it. Then secondary scale is specified by meter just below it, and likewise the tertiary scale is specified by meter just on the left hand side of your vertical line of your tertiary scale. After that, you should find out the RF of that scale. So let us suppose I have some RF like this here, and we should put this RF on the right hand side of your scale, right side bottom of your scale, and you should denote the RF here. After that, our scale is now almost ready. So what we have to do is, we have to draw from each and every point one vertical line like this, and after that on your tertiary scale you should draw one horizontal lines from each of the points. So we will be having this scale ready. After that, as you can see, there are some inclined lines on this scale. So these inclined lines are nothing but our diagonal scale that we are going to learn in this lecture. So after constructing this diagonal scale, what we'll do is, we have to just denote our dimension of this diagonal scale like this, 438 as I will show. So will be showing your dimensions on this diagonal scale. So let us move ahead and see how the diagonal scale is constructed. So how to construct this diagonal scale? So let us see that. So there is a procedure listed here. We will be constructing diagonal scale based on that. But before going to that, let us understand few of the logics or few of the things. So as we know that in your normal plane scale, we can measure unit and its fraction up to only 1 decimal places. While in the case of your diagonal scale, you have flexibility to measure a precise dimensions up to unit and its fraction up to 2 decimal places. That means you can measure up to unit, subdivision, and you can also measure the divisions by this diagonal scale. Now let us understand the procedure of diagonal scale. So now we'll see the procedure. So how to construct this diagonal scale now? So let us suppose we are taking one subunit xy. So let us see there is a subunit xy and we will divide this line into 10 number of equal parts. So I ask you, is it possible to divide this small line into 10 number of equal parts? No. Because if you try to divide very small line into small number of equal parts, then it will be very difficult to identify each of the parts very separately. Let me give you one example of that. So if I say you have to divide the distance between 0.1 cm and 0.2 cm, very small distance, into 10 parts, so is it possible now? No. The answer is no. So what we are going to do here is, we will try to construct 10 lines in such a way that they are in gradual decrement order of the length, and we can have 10 different lines of reduction of length, and we can select any of the line by our usage, and we can plot that particular dimensions very exactly. Don't worry, this is the concept only. This will not be asked in your examination. This is just for your understanding. Let us understand. Let us suppose this is a line between your 0.1 cm and 0.2 cm, and you are dividing this line into 10 parts, but it is not possible. So that's why we will be constructing 10 such lines which must be decremental in length successively. So let us see. Let us suppose this is your subunit xy. Now let us draw one vertical line from y. This will be your line perpendicular to your xy line, and let us denote it by z. Now after that, let us divide this line into 10 number of equal parts. We will be dividing this line into 10 number of equal parts. For our simplicity, let us assume that this line is of 10 centimeters. We have divided this line into 10 number of equal parts. After that, what we have to do is, we'll start numbering from the bottom z here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. After giving the dimensions to this, you have to connect this z with your x. You will be having this hypotenuse. After that, you need to draw lines parallel to this xy line from your points 9, 8, 7, 6, 5, 4, 3, 2 and 1. So we have drawn lines parallel to this. So now we are going to use a similar triangle concept from mathematics to find out the conclusion that what we are actually doing. So let us take two triangles. First a triangle x, y and z. And second let us take the triangle 7, 7 and z. So we will be comparing these two triangles for similar triangle concepts. Let us start with 7z divided by yz equal to 7, 7 dash divided by xy. Now, what we will do is, we want the length of your 7, 7 dash line, right? So, let us convert this equation into 7, 7 dash. So, we will be having the equation like this: 7z divided by yz into xy. Now, we know that 7z distance is of 7 divisions. That means we can write 7 in the place of 7z, and yz is the distance of your 10 divisions, or you can say 10 centimeters. So you can place in the place of yz a 10. multiply by your xy. So now you will be having xy into 0.7. 0.7 means 7 by 10. If you do 7 by 10, then you will be having answer as 0.7. So that's why you will be now having 0.7 into xy. So for 7 dash 9, we will be having the length of 7 dash 9 equal to 0.7 xy. Similarly, let us find out the length of this 1 dash 9. So for 1 dash 9, you will be having the length 0.1 into xy. Now for 2 dash 9, we will be having length 0.2 into xy. If we take the 3 dash 9, then we will be having the length of that line 0.3 into xy. So you can see, if we go progressively downwards, then your length is decreasing from your 0.1 till 0.9, 0.8, 0.7, 0.6, 0.5, 0.4, 0.2, 0.1 into xy. So that means your line is progressively decreasing by 0.1. So as you go down, your line will be successively decreasing in length by 0.1, which is nothing but we have now divided this line xy into 10 number of equal parts, but in our case, we have not shown the 10 parts of this line itself, but we have created or generated 10 lines in such a way that which are successively of a smaller length compared to the other one if we go successively downwards. So this inclined line generated after the construction of the scale is nothing but a diagonal scale. We will be using the concept of this right angle triangle and this inclined line to generate our next scale, which is nothing but our diagonal scale. So let us see examples based on this diagonal scale. But before that, let us see few of the equations which we are going to use in this chapter. So first equation is representation factor. You can say Rn. So it is the ratio of dimension of an object in drawing to the actual dimension of an object. Let us suppose if the dimensions are given in the form of length, then your equation can be modified as length of object in drawing to the actual length of an object. If your dimensions are given in the form of area, then you can write it down as the under root of area of object in drawing to the actual area of an object. After that, suppose if the dimensions are given in the form of volume, then we can write unit of volume of object in drawing to the actual volume of an object. So these are the equations for Rn. Now we need another equation which is known as a length of scale equation, or you can also say the actual length of scale equation. So the equation is Rf into maximum length to be measured. So that means Rf, obviously we are going to find from our previous equations, and maximum length to be measured must be given in your example, for which we must be constructing our diagonal scale. So now let us move ahead and check a unit conversion table. For solving the example based on the diagonal scale, we must understand this unit conversion table. So let us see unit conversion table. 1000 millimeters is equal to 1 meter, 100 centimeters is equal to 1 meter, and 10 decimeters is equal to 1 meter, 1 decameter is equal to 10 meters, 1 hectometer is equal to 100 meters, 1 kilometer is equal to 1000 meters, then 1.609 kilometers is equal to 1 mile, 1 yard is equal to 3 feet, 1 foot is equal to 12 inches, 1 inch is equal to 2.54 centimeters, 1 nautical mile is equal to 1852 meters, and finally 1 meter is equal to 1.0936 yards. We must remember each of the values to easily solve any of the examples based on your diagonal scale. Now it seems very difficult to remember, right? So don't worry. I have a shortcut method to remember this table very easily in no time. So this is your unit staircase. You can use this staircase to convert ideally from your kilometers to millimeters. So let us understand this staircase. As you can see, this staircase, you can see there are number of units written on this each of the stairs, which means that we can convert any of the units which are written on this staircase. If we go up in this staircase, then we need to divide the unit by 10, and if we go down the staircase, then we should multiply the unit by 10. So let us suppose in our case, we are taking one example of 1 kilometer is equal to how much meter? So in this case, we want to convert from kilometer to meter. For that, let us understand our example. So let us suppose kilometer means there is one cat sitting on the top floor of your staircase, which is nothing but your kilometer unit. And you need to reach to this meter unit on the base unit staircase where the shoe is placed. So for that, cat has to descend by 3 steps, 1, 2 and 3. So you are getting down by 3 steps, that means you need to multiply 1 kilometer by 10, and we are descending by 3 steps, that means we need to multiply this 10 by 3 times. So if you multiply 1 kilometer by 10 3 times, you can see 10 into 10 into 10, then we must be having a final unit as 1000 meters. So we can see 1 kilometer is now what? 1000 meters, right? So it is very easy. So you try and paste this method for all of your units. You can see it is very easy to remember each of the units. So now, by keeping this table in mind, let's move ahead and see example number 1 based on your diagrams. Let us read the example first. Problem number 1. The distance between Delhi and Agra is 200 kilometers in a railway map. It is represented by a line of 5 centimeters long. First, find out its RF and you draw the diagonal scale to show single kilometer and maximum of 600 kilometers. Indicate on it following distances. So we need to show, after constructing the scale, the following distances. First, 222 kilometers. Second, 336 kilometers, third 459 kilometers, and last 569 kilometers. Let us first start this example by understanding its statement. So here the distance is 200 kilometers, which is shown by 5 centimeter long line, means a scale is given and we need to use the scale to find out our RF. After finding out RF, we will be using our second equation, which is length of scale equation, or you can say actual length of scale equation, to find out the length of our scale which we are going to draw in our drawing sheet. And after that, finally we will be using these distances to show on our scale. So let us begin with our example. So first we will start with the mathematical calculation. So let us see the mathematical calculation. So first of all, let us find out RF. So RF is nothing but the dimension of object in drawing to the actual dimension, right? We remember the definition. So yes. So what are the dimension of object in a drawing? So in a drawing, it says that it represents a 5 centimeter long line. So that means we are going to draw a 5 centimeter long line in drawing sheet. That's why 5 centimeter long line is there in the numerator, divided by actual length of an object. So what is actual length of an object? So it is a 200 kilometers. So 5 centimeter divided by 200 kilometers. Now we know that RF is what? Unit based quantity. That's why we are having two different units. First is your centimeter and second is your what? Kilometers. We need to convert your kilometers into centimeters. So now we know that 1 kilometer is equal to what? 1000 meters, and 1 meter is equal to what? 100 centimeters. So applying these conversion factors, we will be having now 200 into 1000 into what? 100 centimeters. Now centimeter cut, and if we find out the ratio, then we will be having a ratio of 1 by 14 length. This is our RF. After getting the RF, we will find out the second equation, which is nothing but your actual length of scale. So what is the equation of actual length of scale? Let us remember RF into maximum length to be measured. So here RF is what? 1 by 40 lengths into maximum length to be measured, which is what? Maximum of 600 kilometers. That means you need to put 600. So 1 by 40 lengths into 600 kilometers. Now let us ask ourselves, is it possible to draw 600 kilometers onto your drawing sheet? No. So now we must convert this 600 kilometers into what? Centimeters, right? So once again, let us remember 1 kilometer is equal to what? 1000 meters, and 1 meter is equal to 100 centimeters. We are having two factors. So let us multiply 600 by 1000 into 100. Bracket complete, and after that centimeters. We will be having one line of 15 centimeters. So now the actual length of scale must be your 15 centimeter long line. So let us draw first a line of 15 centimeter long onto your drawing sheet like this. After that, we need to divide this line into suitable number of equal divisions. So what are the number of equal divisions we should divide this line into? It solely depends on your maximum length. So what is the maximum length here? In our case, the maximum length is nothing but what? 600 kilometers. So that's why in 600, zeros are not considered to be your significant digits. That means we are having a significant digit as 6. So we will be dividing this line into 6 parts. So let us divide this line into 6 number of equal parts. After dividing this line into 6 number of equal parts, we will be dividing the first part into further subdivision. So let us divide the first part into further subdivisions like this. So we have divided the first portion into subdivisions. After that, we should give the notation to each of the divisions. So let us start with 0 after the end of your first subdivision, and then as we know we have divided this scale into 6 number of equal parts and total length of scale is of 600 km. We have constructed this scale. That's why if we divide 600 by 6, then each part is consists of 100 km. So we'll start with 0, 100, 200, 300, 400 and 500. Remember, many students are committing mistakes here. In hurry, they tend to write 0, 1, 2, 3, 4, 5, 6. It is completely wrong because we are dealing with 600 kilometers here. So each of the part must be of 100 units. So 0, 100, 200, 300, 400, 500 must be your values. Not 0, 1, 2, 3, 4, 5. And after that, we will start writing for subdivision. So now we know that each of this division consists of your 100 units or 100 kilometers. That means your first subdivision must also contain your 100 kilometers. So we will divide the first unit further into 10 equal parts. So each must contain 10 kilometers. For that, we can write down sub-unit as 0, 50 and 10. So 0, the 5th division would be 50 and the 10th division would be 100. After that, you need to draw this vertical line, which is a width of your diagonal scale. So here in our case, we are dealing with the meters, so that's why I will be taking this diagonal scale height as 10. Why 10? Because we will be having this subdivision in the secondary scale of 10 kilometers. So we can divide this 10 kilometers further into 10 equal parts while constructing a tertiary scale. So we can divide this tertiary scale into 10 parts. How we can decide the 10 parts? So we know that your secondary scale consisting of 10 kilometers each divisions. So if we are drawing a vertical tertiary scale from your 100th division, then it will be consisting of your 10 kilometers. And if we are having a 10 kilometers, then we can obviously divide that line easily into 10 number of equal parts. So for that we will be constructing the tertiary scale into 10 number of equal parts. And if we are going to construct this tertiary scale into 10 number of equal parts, so we can either draw a 10 cm vertical line or we can draw a 5 cm vertical line, and we can divide this line further into 10 number of equal parts. So now let us draw vertical lines from each of the points. So we have drawn vertical line from 500, likewise 400, 300, 200, 100 and 0. So you must draw vertical line from each and every part. After that, you need to draw 0 to 10 on your tertiary scale. But we know that when you are starting from your bottom points, it must be your 0 kilometer. For that I am starting with 0 kilometer. If I go upward direction, we will be having incrementing the orders 1, 2, 3, 4, 5, 6, 7, 8 and 9 on your tertiary scale. After that, drawing your tertiary scale, the 10 of the points, you need to draw horizontal line from each of the points like you can see. And after that, we will be specifying the units on each of the scale. So as we are dealing with kilometers throughout, so we are putting primary scale as kilometers, secondary also kilometer and tertiary also a kilometer unit. After drawing the scale, we should specify the RF. So we will be showing RF on this right hand side. As you can see, RF is nothing but 1 by 40 less. Now we have almost constructed our scale. Now I have said you that we are going to construct a diagonal scale here. So where is the diagonal scale? Wait, we are just starting with the diagonal scale now. Be careful and listen me carefully, because the next steps are very important to construct your diagonal scale very precisely. So what you will do? So you have to find out the leftmost corner point top. So you need to first find out your leftmost top corner point, which is showing 10 there. So you identify your point there. Then after, you should go at the bottom of this vertical line, you will have 0. On the right side of the 0, you will be having first division, subdivision on your horizontal scale. So now you need to connect the leftmost top corner point 10 with your first subdivision from 0 on your right hand side by this straight line, as you can see now. So you can see it is an inclined line. It is something like your diagonal scale, which we have seen in our previous topic. So now what we have to do is we have to just use our roller scale or drafter. So you need to place your roller scale or drafter onto this inclined line. So now your line would be at the same angle as that of this line. And after that, you need to just draw parallel lines to each of the subdivision on your horizontal scales like this. And if you start drawing the parallel lines to each other until you reach 0 on the scale, then these lines here are nothing but your 10 diagonal scales. So now your scale is completely ready. So this is your scale, which is nothing but your diagonal scale. After that, let us focus on the second part, in which indicate on the scale the following dimensions. Now we are going to indicate following dimensions on the scale. So which are the dimensions which we need to indicate? So here there are 4 dimensions we need to indicate. We'll start with the highest dimension first, which is 569. So what we do is, we will break this 569 into 3 categories because we are going to use the 3 scales. So let us divide this 569 into 3 parts. 500 plus 60 plus 9. So we have 3 scales, so that's why we have divided this 569 into 3 different units. 500, 60 and 9. So first of all, we will measure 500 on this scale. This scale will, primary scale will indicate your 500. 60 will be indicated by the secondary scale, meter scale on the horizontal line, and the third scale, which is 9, which will be indicated on the diagonal scale, means your inclined line. So let us start indicating your 569. So what we'll do is, now let us start for the primary scale. So as we start from 0 towards the right hand side of the main scale. So let us start 0, 100, 200, 300, 400, and 500. Let us draw a vertical line. Now next is your 60. So let us draw from 0 till your left hand side for 6 division. 1, 2, 3, 4, 5, 6. So you will be having your division just on the left hand side of your 50, so which must be showing you 60 distance on your secondary scale. And you are seeing that there is one inclined line passing from your 60 division. So now you have to go up by your 9th division because we are going on the tertiary scale now. So in tertiary scale we will be having 9. So you have to go 9 points up on your tertiary scale, starting from your 60 division at the bottom 0. So on 60 division, just on the left hand side of your secondary scale, you need to go up 1, 2, 3, 4, 5, 6, 7, 8 and 9. So you will be having this point on the 9th division on your 60 line of your secondary scale, and this is nothing but your 69. After that, you need to just draw one vertical line from this great point, and then after you just connect these points, and you will be having your dimension, which is 569. Once again, 500 on your primary scale, 60 on your secondary scale horizontal line, and you need to go on that inclined line 9 points upwards on that inclined line itself. You will be having that point 9. So on 60's inclined line, you will be going up until you reach the 9th number point horizontal line and the intersection of 9th horizontal line. At 60's inclined line, you will be having one point, which is nothing but your 569. Very easy. So let us see one more example. We will be taking a third number first, which is 459. So let us start dividing this number into 3 numbers first. 400, 50 and 9. 400 we are using this primary scale. So let us start 0, 100, 200, 300 and 400. So let us draw one vertical line from 400 like this, as I have drawn. After that, we need to find out 59. That means we need to find out 50 on the secondary scale. So 0, 10, 20, 30, 40 and 50. As you can see on the secondary scale, 50 is indicated there already. On this 59 now, this 50 is inclined line, you need to go up by the digit. Here it is given 459. So we need to go 9 steps above in this line of 50. So let us start with 1, 2, 3, 4, 5, 6 and 9. So we will be having this 9th horizontal line and 50's inclined line. So this must be your point, which is the intersection of 50's inclined line and 9th horizontal line. So this is nothing but your 459. Now let us see one more unit, which is 336. So we can divide this 336 into 3 parts, 300, 30 and 6. So now let us first plot 300 starting from 0 on the right side, main scale, 0, 100, 200, 300. Let us draw one vertical line. After that, 30, so let us go on the secondary scale. On the left hand side of the 0, 10, 20, 30. And on your 30's inclined line, you need to go by 6 steps up. So 1, 2, 3, 4, 5, 6. So this will be your point, which is the intersection of 6 horizontal line and your 30's inclined line. This is nothing but your 336. After that, let us see one more example. First one, 222. So 222 can be broken into 3 parts, 220 and 2. So let us start with 200 on this primary scale. So 0, 100 and 200. So let us draw one vertical line. After that, 22, that means we have to go on the secondary scale. So 0, 10 and 20 on the left hand side of the secondary scale, and after that you need to go by 2 steps up. So 2's horizontal line and 20's inclined line would give you a red point, and which is nothing but your 222. Very easy. So remember, to construct the scale, the data required is first RF of the scale, the second unit which plot like millimeters, centimeters, meters or kilometers in MKS, yards each in FPS. Third, the maximum length to be measured, and if the maximum length is not given, then you should select any suitable length as a maximum length. And fourth and final one, the actual length of scale must be known, which we are going to use to draw a scale. The equation shows that RF into maximum length to be measured. So that is all from my side. If you have liked my lecture and teaching style, do not forget to like, share and subscribe to my channel. Keep learning, stay connected. Bye-bye.